In this video, we're going to talk some more about useful tools that can be used to help process string data. This specific video covers how to use a loop to process individual characters in a string, and also how to convert a string value into an integer or other numeric data type. These particular operations will turn out to be very handy, potentially with some upcoming software programs that you need to write for projects. So first we want to remember that Python includes a special loop that helps us process information in lists, and the same loop works well with strings in Python. So it's a special loop that helps us iterate through all of the individual items in a list is the for loop. Remember that iterate's just a fancy computer science word that means consider all the iterms in order individually. So consider the items individually in sequence or in order. To iterate over all the characters in a string means to process the individual characters one at a time, starting with the leftmost character and stopping when we've processed the rightmost character. So the syntax for that particular kind of loop is right here. You put in the reserved word for, that's what tells Python that we're using a repetition structure. Then you provide an identifier that you'd like to use to reference each character in the string. I chose CH. Then you use the reserved word in and give it the name of the string. Then include your colon to show that you're starting the loop body. And then put all your loop body statements right after that. You want to make sure you indent them. That's how Python knows that they're part of the loop. So for example, if we wanted to print a asterisk symbol after each character in the name Smith, we could write this loop for CH in last name, print the character CH, and then also print an asterisk after it. So if we created that in idle and we ran our program, it would go through and it would pull out the first character in the name Smith, the capital S, and it would print that to the screen, followed by a asterisk. Then it would move on to the next character in the name, that's the M, print that, and then the asterisk. And then it would move on to the next character in the name, that's the I, and then it would print the asterisk. Move on to the next character in the name, that's the T, and then it would print the asterisk, and then finally it would print the H and the asterisk. Once it gets to the H and it's printed that out and it goes through to look for another character in the name, it would realize there's no more characters and it would terminate that particular loop. So the for loop's really handy. It works well when you're processing all of the individual characters that are part of a string. Now sometimes you might allow somebody to enter information as a string, but you might want to treat it as a numeric piece of information at some point. So for example, if you were reading something like a credit card type and you wanted to use information or some of the useful tools that we've learned about so far to find the length of that credit card number and what the beginning prefix was, you could use all of those values. Then if you needed to use like a formula on part of the credit card number, you might want to turn some of those digits into numeric values. And Python has a way to do that. So the way that we're going to do that is by using the eval function. That's one of the ways where you can tell Python that you want to treat string information as though it's a number. We've seen that in lab a few times where sometimes when I'm reading data from input, instead of putting like int or float in front of it, we put the word eval, and that tells Python that we want to treat it as a number. We're going to use that same process to tell Python to treat information from the string as a number. So if we read in something like a student ID number, we could do things that process it using the useful tools that we can use with strings, like looking at the first character. But then if we wanted to process information about that first character and use it in like a formula, we'd have to turn that into a numeric value. And we do that by putting the eval method right around the character that we want to change. So saying first digit equals eval first character takes my first character. So that would be like the character value of the number. And then by saying eval, it's going to give us the equivalent numeric information from that number and then print it out. This works a little bit different than the processing that we were doing in the lab last week, where we were looking at the ASCII value of a number. This is actually going to turn the digit into the numeric digit that's equivalent. I think it's probably easiest if we look at that in Python so you can understand what I'm talking about. Let's do a new little example file here where we ask the user to enter a number and we store it as a string. So if we say, please enter your ID number. Again, it's not going to store it as a number because we didn't say int or eval here in front of input. It's going to automatically store it as a string. And then we can perform string operations on it. We could do something like length equals len of the string ID number and print that out. And then if we wanted to use this eval method to pull out a single character and print the numeric value of it, let's first print out the first digit, or the first individual character in the ID number. And then let's also convert that so that it's a digit. First digit equals and then let's print that out. Now we need to run our program. So it says enter your ID number. I'm going to type in 1, 2, 3, 4. So it tells us the length of it was 4. It was 4 characters long. And then it gives us the first character, which is a 1, and then the numeric equivalent of it, which is also the number 1. And those look the same when they print out, but trust me that Python's thinking of this as like single quotes 1, single quote the character, and it's thinking about this one as the number 1, an integer value. You might wonder, like, why is that important? Well, it's important because sometimes you want to be able to perform a numeric operation on it. Like, suppose we wanted to multiply it by 2. Let's see the difference between those two answers. So you print first, or do, I didn't store it as a first character. First character is ID string ID number at index 0. So if we do print out the first character times 2, I spelled it wrong still. All right, and then we did print first digit times 2. Those are going to have 2 different outcomes. Move this around a little bit. Okay. I'm going to type in my ID number 1, 2, 3, 4. It's going to tell me the length is 4. Print out the first character, which is 1, the numeric equivalent, which is 1. Now note when we print out first character times 2, it repeats the same character twice because it's performing the string version of this multiplication or repetition operator. But when we say print first digit times 2, it takes the number value because that's the first digit value and then multiplies it by 2 as a number and prints that out. So this is going to print, in the example here, it would print if the ID number were 1, 2, 3, 4, it would print 1, 1, because that's the first character repeated twice. And then on the next line, it would print 2, the numeric value of 1 multiplied by 2. So let's try a few more problem-solving activities. Let's try to write this program that asks the user to enter a date in the format month, month, day, day, year, 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 and then prints the value of the date in that same format. So take a second, pause the program, see if you can come up with a solution to that. Then we'll write one together. Whenever you're done with your ideas, you can unpause the video so that we can build it together. So we want the user to enter the date. So we're going to prompt them to enter that. And we want them to enter it in month, month, day, day, year, year, year format. And then we want to print it out in a different order. We want to print the day first, then the month, then the year. So to do that, we need to pick apart the information that's entered by the user. They're going to enter something like 03182020, and we want to pick out certain characters from that to print first. First thing we want to print is the day. So we have to think about what index would be associated with that day character. So it would be 0, 1, 2, 3, and then also character 4. So we want to print the date that they entered at index 3, and then the date that they enter at index 4. And then we want to input or print out a slash, because we want the slash to follow the DD. Then we want to print the month next, and that's the values that'll be at indices 0 and 1. So I'm going to print date at index 0 and date at index 1. And I'm just concatenating all these values together. And then finally, I want to print out the year. So that'll be the date that's at index 0, 1, 2, 3, 4, 5, 6, and then 7, 8, 9. So I'm going to do 6, date 7, date 8, and then date 9. If you were thinking you could use a slice there instead of typing all those individual values, you are absolutely correct. So let's try that out. So if we enter 0318, 03/18/2020, then the program switches it so that it prints the date first, that's the 18, and then the month, that's the 03, and then leaves the year at the end. Let's try a second program. This one is going to detect whether a string entered by a user is a palindrome. That means it's the same spelled forwards and backwards. Again, pause the video, see if you can come up with a solution to that particular problem, and then we'll build it together. So if we want to see if a string is the same forwards and backwards, that would be like if we had like A, B, C, D, C, B, A, that would be a palindrome because it's the same forwards and backwards. So to do that, first we need the user to enter the string. I'll say string to check equals input. Please enter a string to test for palindromeness. Now we want to process all the individual characters from the string. We don't know how many there are necessarily because the user might type a string in of any length, and we want our program to be really flexible and work with all of those. So let's make a loop that checks to see, checks each character in the string. So we know that we can use that for syntax for each character in string to check. Let's think about what we want to do. If this character is at the beginning position, we want to look at the character that's kind of like at the opposite position. I think we're going to need a position index, where I'm going to make position equal to the length of the string to check minus 1. I think that's going to work well. Okay, so then for each string in the, or each character in the string, I want to check to see whether if the character that I'm looking at is equal to the value in string to check at position, then that means that we're good. It's still probably, or it's still potentially a palindrome. But if we ever get to a point where it's not the same, then we want to stop checking because we know it's not a palindrome. So let's make a variable palindrome and set it equal to true initially. If we ever find a character that doesn't match with its reflection, then we're going to set palindrome equal to false. And then at each iteration, we want to update the value of position so that it's 1 less than its current value. I think that's going to be good. So then at the end, if palindrome is true, then we want to print out a message saying string to check is a palindrome. And then otherwise, we want to print out something saying it's not. All right, cool. I forgot to capitalize the F for false. All right, I think that's going to be good. Let's try running it. Oh, I've messed something up. Oh, I forgot my colon. Try it again. So we need to type in a potential palindrome. So let's try ABC. That's not a palindrome. Oops, I got another typo in there. Where did I use true? Oh, here. One more time. So we type in ABC. This one equals string to check minus 1. Oh, I wanted to put the length of the string to check. I think I even said that, and then I didn't type it. Length of the string to check minus 1. Tells us it's not a palindrome. That's a good sign. And see, even when I'm typing in little programs, I have to like go through it a lot of times. I know sometimes you guys get frustrated when you're writing your own programs and you get lots of compilation errors or runtime errors, but that happens to everybody. All right, let's try it with something that is a palindrome. ABCBA. Says it is a palindrome. Let's try it with another one just to make sure. Try it with like a really long one. B, C, D, E, F, G, F, E, D, C, B, A. Awesome. So I think our program works well. Again, this one was a little bit confusing, so let's just walk through it one more time so that you can see what the logic of the statements in the program are. The first thing we did was we allowed the user to enter a string to check to see if it's a palindrome. We set up a variable called palindrome that starts out being true, and then we change the value of that variable to be false if we ever detect a situation that lets us know there's no way that's a palindrome. And then we can use that value at the end of our loop to check whether it is or isn't a valid palindrome. The other thing we did was set up this position variable. We need that so that we can compare each character in the string to kind of its reflection on the other side of the string. And I set it equal to the length -1 to start out with, and that's because that's the largest index that's part of the string. The smallest index is always 0. The largest index is always the length -1. Then I used my for loop syntax to go through each of the individual characters in the string. And each time we look at a character, we compare it to its reflection on the other side of the string. If those don't match, we know it's not a palindrome. If they do match, we know it might be a palindrome. We have to check more characters, potentially. And we do that by decreasing the position each time. Python automatically increases the character so that it moves over to the right a little bit more each iteration of the loop.